Oh, hello. I didn't see you there. Let me welcome you back to Richerthanthou's Corner. Come up with a new name for it. It's wonderful. Today, we will be talking about basic atomic stuff, which means basic stuff concerning the atom. There will even be mention of Richerthanthou, the man we have already talked about. So prepare yourself to delve deep into the shadow of this topic. First, I would like to talk about the basic structure of an atom. An atom is made up similarly to a sci-fi energy core. You see, the center is a nucleus. It is made up of neutrons and protons. Around that are shells, like energy shells, and around those orbit electrons. Now, what are neutrons, protons, and electrons, you might ask? And I will tell you. A neutron is neutral. A proton is positively charged, electrically that is, with a charge of +1. An electron is negatively charged, electrically that is, with a charge of -1. Next, I'll tell you a thing or two about isotopes and radioisotopes. Yes, but not like the radio that you listen to music on. No, not that kind of radio. It's a different kind of radio. I'll tell you about that in a second. Isotopes are a stable nucleus. If an element has an atomic number, which is the number of protons or neutrons in the nucleus of an element, of an atom, of an element. If it has an atomic number of 83 or less, it is stable and it's an isotope. However, if it is any more than 83, it is a radioisotope, which means it is an unstable isotope, which means it's a radioisotope, because here's where the radio comes from. It's radioactive, as in boom, boom, boom radioactive, like the atomic bomb and nuclear weapons and those things that I may or may not sell to the Middle East. It's not important. I'd also like to tell you a thing about relative atomic mass. Relative atomic mass is actually the same thing as just saying the atomic number, or the atomic mass. Relative atomic mass is more specifically the average atomic mass. But the thing is, that's what's on the periodic table, so you don't even have to worry about that. You only have to worry about that if you're a chemist, like Dr. Subatomic. He's a good man, good man. Now, I told you about the shells with the orbiting electrons in the atomic structure. Now, these are called energy levels, alright? And an atom has multiple of them, multiple. And each one may or may not have multiple electrons. May or may not, may or may not. When it comes to what they are, I've already told you what they are. They are shells of energy that electrons revolve or orbit around. Now, there are also sublevels, which are just smaller levels. Of course that makes sense, of course. Anything I say makes sense, of course, of course. And the first 4 principal energy levels and the maximum number of electrons in the sublevels that can be contained are summarized by this chart. Take a good look at that chart. That chart is important. Look at it, it's gone. Bye-bye chart. Now, see you after this. Oh, welcome back. Didn't see you there. Now, let me tell you something. This is important. You want to listen to this. This is about subatomic evidence and what we look at when we want to see the atom. Now, you probably just know it as the atom because we don't care about any of the ones that came before them. They were wrong. Who cares about wrongness? No one. Of course not. There is one that is indubitably the most important. It is the Rutherford Bohr model. That's right, Rutherford helped make it. That's why it is right. Because Rutherford helped make it, and he is my ancestor, and my line is the best line. Because I am rich, and you are poor. And I am rich because I am still swimming in the money from his discovery. Yes, yes, yes. The atom, Rutherford Bohr model, this thing, that thing right there. Take a good look at it. That is my heritage. Moving on. Get that out of here. Get that out of here. Get that. Moving along. Now, you might wonder, how did we get there? Well, I'll tell you how. Atomic emission spectroscopy. I'll tell you what. We're going to call it AES. AES. We're just going to call it that. What is AES, you may ask? I'll tell you what. It is something that chemists use to determine the quantity of an atom in a given sample. How does it do this, you might ask? And I will answer that question. It does it by using the intensity of light emitted from fire, plasma, an arc, a spark, and those sciencey things. They use it not just by itself, but at a specific wavelength. And I'll be back to talk to you specifically about the specifics using an example of the best element that exists. Welcome back. Now, I told you I would use a specific element. Let me tell you what that element is. Gold. Gold, gold, gold. It's the best element that is. Atomic number of 79. You may know gold as precious metal, but in the world of science, it is so much more. Gold has 35 isotopes. Gold 170 all the way through gold 205. Now, the most stable of all of them is gold 195. 195. Most stable one right there. Now you may be wondering, what do we use it for? You know that it is used for coins, medals, jewelry, art, all of those things. I use them for everything I can. Why? Because it's expensive and I can. Take this microphone, for example. This microphone is gold-plated. Why? Because I can. That's why. Because I am rich, and you are poor. Now, let me tell you a thing or two about gold. Moving along from the fact that, yes, it's pretty and we use it for pretty things. In science, it is used completely for a different reason. What is it used for, you may ask? I'll tell you what we use it for. When it comes to its radioisotope, which is gold-198, because most elements, even if they are 83 or under, atomic number-wise, they still have at least one radioisotope. What does that mean? Radioactive. That's what it means. Just remember that. Now, when it comes to science-wise, it has a large use and a number of uses in industry and medicine primarily. What is it used for in medicine, you may ask? Do we gold plate people's heads? No, I'll tell you what we use it for. We use it to treat ovarian cancer. That is right, ovarian cancer. The number one killer of women out of all the cancers. That's right. Get in line, breast cancer. Get in line. I'm watching you, breast cancer. Now, do you remember the AES that we talked about earlier? Well, gold has one of these, as all elements do. And here it is. Look at it. Look at it. Look at it. Long, black background, pretty colors. Look at the pretty colors. Look at the pretty colors. And now it's gone. Now it's gone. Now, electron configuration is the arrangement of the electrons in the orbitals of an atom. And that's the shells that we talked about earlier. It's the placement of the electrons in the shells. Here, let me tell you what's in each electron field. Now, the first one, there's 2. Count it, 2. Now, the second one, there's 8. Alright? Now in the third, 18, fourth, 32, fifth, 18, and sixth, 1. He's very lonely out there. I'm just putting that out there. There you go. That's everything you need to know about gold and basic atom stuff. There you go. Thank you for joining us in Richerthanthou's Corner.
I will now administer a brief quiz to assess your understanding of the information presented to you in this lesson. Number 1. What is in the nucleus of an atom? Answer: protons and neutrons. Number 2. A. What is the number that you should always remember when determining the radioactive positivity of isotopes? Answer: 83. B. Is the atomic number determined radioactive when above or below 83? Answer: above. C. If an element's atomic number is 83, is it an isotope or a radioisotope? Answer: isotope. Number 3. What is relative atomic mass? Answer: the average atomic mass of an element's atom. Number 4. What is the total number of possible electrons that could be orbiting in the first atomic sublevel of an atom of any given element? Answer, 2. Number 5. What is the modern atomic model? Answer, the Richerthanthou model. Number 6. What does AES stand for? Answer, atomic emission spectroscopy. Number 7. What is the most stable gold isotope? Answer, gold 195. Number 8. What is the first color, moving from left to right, on gold's atomic emission spectrum? Answer, purple. This now concludes the quiz, and thus the video. Hail robots everlasting. Goodbye.